one of the switches as we've grown into these complex distributed systems is starting to understand that failure is the normal. Like things almost always never work exactly as intended.
ברוכים הבאים לפרק נוסף של בוקר קוד, פודקאסט על תוכנה, תהליכים ואנשים שביניהם. אני ייסן ריפקין, המנחה שלכם, ובפרק זה נצלול ראש של תחום חדש ופחות מוכר. זהו העולם של הנדסת כאוס, ובסופו של פרק זה, גם אתם תבינו במה מדובר בפעם הבאה שתצטרפו לשיחה בכנס, והמילה כאוס תעלה. לטובת פרק זה חיפשתי בקרב מומחים ומצאתי אורח מיוחד, ייסון מחברת גרמלין, אשר בונים מוצר בתחום. בעברו עבד בחברות מעניינות כמו MongoDB ודאטאדוג. הפרק יעשה בשפה האנגלית לטובת האורח שלנו. סליחה מראש על האנגלית. Jason, hi, welcome and thanks for being with us here today. I'll just start with asking, tell us a little bit about yourself.
Yeah, thanks. I guess where to start a little bit about myself. Yeah, I've been in software development and, engineering for quite a while. I think like a lot of folks, started out as a kid with a computer and learned how to program because it was interesting and really found that niche there. And so that sort of progressed up through, university. I didn't actually study computer science. I thought I'd be more on the front end. So I got into design. And this was in the days where, there was just all the browser incompatibility, right? We had like Netscape Navigator and early Internet Explorer, and it was all kind of garbage. And that led me to doing backend code because I was like, at least it all runs the same. And obviously back then it was like you had to set up your own server and like install Apache and all this stuff. So that kind of naturally led me to do, full stack back then, which was like systems administration work all the way up through the front end. And I really liked actually setting up servers and that engineering side. So over time, I kind of trended that way into getting into, now what we call DevOps and SRE work, and naturally led me to sort of discovering this idea of chaos engineering and breaking things to test reliability and improve things.
It's actually interesting that you got into this field because for most people, they never heard about it. So I would say that for me, the first time I heard this term was actually in KubeCon San Diego 2 years ago. I guess I wonder, how did you get into this field of chaos engineering?
Yeah, so I had first heard about chaos engineering, I think the same way that a lot of folks did, through Netflix. And so, this was ages ago, but Monkey. Netflix, they released this tool called Chaos Monkey, and they had this blog post, and it was right when they were moving from their own data centers to embracing AWS. And so they had this idea that with AWS and with the cloud in general, there's no guarantee on reliability, but what you're guaranteed with the cloud is the ability to just have on-demand resources, right? You can spin up a virtual machine almost instantly and have these things. And so their notion was, if that's the case, maybe we should build a system where things can just die, and we don't care if a server dies because it's easy to provision a new one. So if you're constantly just like losing servers, but you have new ones, then you don't really have to worry about keeping something up, with years of uptime, like a single server.
Yeah.
And so they had written that post, and they talked about it actually at a time when I was working for O'Reilly, the tech book publisher with the animals on the cover.
With the animals. What's this? How do they pick the animals, by the way?
That's a great story or question. So to dive into that, the animals are chosen almost seemingly at random.
Really?
Based on a book will come in, and Edie Freeman and her team. Edie is the woman who first knew Tim O'Reilly, and she was an artist and drawing the animal pictures, and has then joined the company and is now responsible for a lot of that. And so a lot of times it's just, they'll kind of take the top and think about it and sort of match it up with an animal.
Gotcha.
So there have been some great animals selected, partly due to the influence of the community managers that are working at O'Reilly.
Interesting. And then how did you get to chaos engineering? How did you hear about?
So I was involved with the Velocity conference, which was all about DevOps and performance. And so they gave the talk there, and I was like, oh, this is really fascinating. And it wasn't until I then joined Datadog that I actually was able to experience some of that. So at Datadog, for those who don't know, is a monitoring and observability company. They run a giant Kubernetes cluster. And so obviously, if you're providing critical, system and monitoring for other folks, you can't go down, right? If you go down, it means that all of your customers have no clue. And if they're having an incident, it makes things worse. And so they started to get into the practice of chaos engineering. And that's partly due to just some really talented engineers. And also at the time, our director of SRE, a guy named Corey Bertram, actually had come from Netflix. So he was experienced with the chaos engineering.
Oh, sure.
So we started introducing it at Datadog. And so that's where I had my first opportunity to really get involved with that. Obviously, chaos engineering is a good way to promote monitoring, because it's really hard to understand what you're doing if you break something and don't have monitoring. So I started talking about it quite a bit. And that ended up leading me to find out about Gremlin. And so I had partnered with Gremlin on a few different activities to train people how to do chaos engineering. And ultimately, that led me to joining the company.
Thank you for that. So it's an interesting path. Your title statement is Director of Advocacy.
Yeah. So developer advocacy or technical advocacy really is this job where I'm tasked with going out there and educating engineers and developers and helping them to become better, which I really love. And so there's a few different portions of that. To take a step back, the way that I got into this basically was as an engineer, I would always just take notes. Whenever I solved an interesting problem, I would just start to take notes for myself. And eventually these became blog posts. And they were really useful, primarily just for myself. And eventually realized that this is actually something that I really loved more than actually doing the engineering work.
Yeah,
I really liked to help other engineers get better and learn things. And I quickly realized that this could be a job. Companies pay for someone to go do this. And so that's what led me down this path. So at Gremlin, advocacy largely revolves around education, teaching people how to do chaos engineering, and really just inspiring them to try it and adopt it as a practice.
Sure. So this is awesome. And with that said, what is chaos engineering?
Yeah, that's a great question, because I think there's a lot of misconceptions around this, right? Because we've talked about Chaos Monkey and how the idea was to randomly take down servers. But chaos engineering has basically evolved into a process. And the way that I like to sum it up is, can you validate that things work the way you expect them to, right? That's it in a nutshell. And there's a larger process, and the larger process involves taking observations of whatever you're working on, the systems that you're responsible for, making a hypothesis about how you think they'll respond to some sort of failure, and then intentionally injecting that failure to prove whether your assumptions or your hypothesis is true or not. So that's kind of the overarching process around it. But really, it comes down to the fact that we need our systems and applications to be reliable. And the only way to ensure that they are is to actually test them and try to cause some failures to ensure that they respond in the ways that we think they should.
One of the statements that you say here is proactively improve reliability. So it makes sense. And what do you mean test that your hypothesis? For example, we at SimilarWeb, the company I work, we have those cross-region setup of Kubernetes clusters where we serve our customers from two regions at the same time. And we do this failover if there's an issue or outage in one region with this simple Slack command. Our hypothesis is that everything is replicated, so there's no single point of failure. So all the databases, all the pods, all the code, all the endpoints, everything is replicated between two regions. So if a full region of AWS falls, the other one keeps serving perfectly. So this is an hypothesis, right?
Yeah, exactly.
But then comes the actual outage.
So yeah, that's where chaos engineering comes into play, right? Is you could either wait for an actual outage and then, I don't know, hopefully things work, right? You're probably excellent engineers and we all hope so, but you know, we work with such complex systems that things never work quite as we expect them to. There's always something, even if they work out great, you can always learn something when something actually happens. And the problem though is oftentimes that thing you learn can be very painful. Worst case is that there was no true multi-region redundancy, data got lost, and now your customers are angry, or you lost a ton of money, or whatever that might be. And so the proactive part is, well, if we think that we have multi-region redundancy, what happens if we just proactively take out one of those regions, right? We stop serving traffic to it.
Actually, if I can ask you this, like in a very simple, to dumb it down in a very simple way, basically you're saying, hey, you have these complex distributed systems. You think you know what they're doing. So much open source, everybody build, like so many black boxes speaking together, everything dynamic. And you have this assumption that stuff should work in some way. And with like, just test it, like break stuff and see how it works.
Right? Yeah.
Okay. But I'm sure there's like a but here.
Yeah. Yeah.
Because I cannot just take down production.
I mean, you might get yourself fired. So if you're listening, do not do that. Don't go straight into production. But, you know, I always emphasize that that's not how we do any development anyway, right? If you're a developer, no matter what part of the stack you're working on, or an engineer, you never just do things directly in production, or you shouldn't. If you are, I would highly advise that you stop doing that, because that's extremely risky. We always work, you know, local development, and then to, some sort of cloud development environment. And then we push to staging. And along the way, there's, your build pipeline. And so you're doing a lot of tests in this process, whether that's, again, your application or your infrastructure. We do a lot of this testing. And by the time we push out to production, we're highly confident that the code we're deploying out there is relatively bug-free. It's going to do what we expect. And so the same applies for chaos engineering. If you're trying to do it directly in production, that you're going to have a bad time. So start off simply, right? Like, what's a small test that you can do? Your development environment probably has some sort of simulation of production systems, whether that's either locally replicated or they're interfacing with other development environments. But it's pretty easy to test locally and take things out and see what happens. Now, obviously, your development environment is nothing like your production environment in terms of scale and traffic and everything else. But there are some basic things that you can test for. For example, if a region does go out in production, what would that look like, right? What would it look like for some of your services to not get the traffic that they're expecting, right? In terms of monitoring or the messages that they're producing, the observability that you have. There are ways to start to test this at a small scale and then work up to your staging or your QA environments and continue to test, so that by the time you're doing it in production, you should have some confidence that the things that I've tested have worked before, they've worked in all the other environments. So now we're comfortable.
So let me ask you a question of like a recent incident I experienced. We have this database multi-node cluster with the leader and followers, and you can only write to the leader node. And at some point, the leader node died, and the leader was switched. There was like a leader election, and the new leader popped up. Those servers are really stable usually, so you don't feel this too much, but it happened and it's fine. And it's a complex system and it worked great. The issue that we discovered that some applications, when only looked at the endpoint of the writer node of the leader on startup. So then when the leader changed, they crashed and they went back to working, but only after startup again, because they got this. So and then you're like, okay, so this system works great. Like the database cluster was okay, but actually all of the applications did not prepare for a leader change. And I wonder, is this something that you can actually test in production? And how would you do that in the sense that it also involves other services? So I would take down the leader and see that a new leader pops up, no data loss, everything's accessible. And I would say like, okay, cool. Like the systems are perfect.
Yeah, that's a fantastic question, right? Because as we have more of this world of microservices and separate teams, there's often a disconnect of what a service team expects, the applications or services that are looking at that database, and you on the ops side that are managing that infrastructure and keeping that database running. So one of the great things about chaos engineering that we found is, or actually I should say two of the great things. The first is that I highly recommend that people do what we call game days, and that's bringing together not only their team, but multiple teams to actually try these out, right? And have a time where you can work together. This really goes back to that root of DevOps breaking down those silos and having developers and service teams work with operations engineers and removing some of that friction. So that's one great thing is, yeah, you could absolutely do this, bring teams together and actually test it out. The other great thing though about chaos engineering that I've been finding over the past couple of years at Gremlin is there's a lot of ways that teams themselves, as we do this sort of reliability shifting left, and not just being the SREs and just being the DevOps folks, but really just being, can we shift this left? Can we make reliability an important part for service teams? And so there are a bunch of ways that you can do that with just the service team itself and not even involve your database or your operations team. You can do things like what we call black holing a system, which is basically cutting off the network traffic. So identifying what is that host name or IP address for the database, and can we actually cut that off on our application side to make it seem like it's down even when it's not, and see if it actually does try to look for a replacement or actually refresh and see if there's a new IP address or host name for a leader when it can't access the endpoint that it had been looking at before.
So this sounds like, even before it's an engineering problem, it sounds like a human issue. I mean, to create this thing, you have to kind of coordinate between teams, right? And everybody have to be on board and want to do this and find the time and schedule a day. So I guess it has to be a priority.
Yeah, it absolutely does. And that's one of the biggest challenges, right? I think up until now, the practice of software development and everything that we do is surprisingly optimistic. We always write code, and in the back of our minds, we know that something could go wrong. And so we often think about what are the edge cases. But I say that up until now, things have been very optimistic because traditionally, I think we write code, and the way that we traditionally write tests is the assumption that things will keep working. And one of the switches as we've grown into these complex distributed systems is starting to understand that failure is the normal. Things almost always never work exactly as intended. So we're always living with some sort of inefficiencies or brokenness in our systems. And really adopting that mindset starts us thinking more about, well, how can we make reliability more of a priority? And that hopefully leads people to trying chaos engineering.
I feel that very much from a different perspective, where in the past you'd never hear this term, but now the term exponential backoff and retry on the client side, it's so normal. It's like saying you have unit tests. If you have a client that's connecting to some other service, you want to have it like a retry mechanism and things like this. And I can even see like these small features of enabling chaos in your system in different places, even like Istio, the service mesh on top of Kubernetes. When you deploy a service, you have this flag when you can say, okay, create some latency. Let's actually simulate. And with that said, I really want to ask you, so what do you do? Okay, I gather the people. How do we choose what we want to target? Because I guess creating chaos around some niche deployment where nobody cares doesn't have too much value. What do you actually do? What tools do you have? What do you need to prepare? And how do you measure this?
Yeah, there's a few ways that you can go about doing this. And I feel like every company that I've worked with does things a little bit differently. So some of the common ways for example, when I was at Datadog, it was about, again, that process of starting small. And so we had basically 6 levels of tests, and they ranged all the way from level 1 is the turn it off and on again, right? That's like, number 1 IT rule, right? If it's broken, have you tried turning it off and on again?
Yeah.
And that works for our services as well, right? When you see something that's broken, whether you're in Kubernetes or if you're still working on VMs or whatever, number 1 thing is, this pod is acting weird, right? So let's just delete the pod and Kubernetes will recreate it and see if that fixes it. And so for me, like that was always the first test that I would do is if I delete this thing or if I turn it off, we work with systems that are so automated now that being able to automatically restart is like, it's just the baseline. If you don't have that, then like you're doing something extremely wrong. So start there.
Yeah, okay. So it means we can stop servers, kill pods, delete deployments, install them.
Yeah. And then from there, we would usually start to test things like dependencies, right? What happens when you mentioned the database, right? If I had that service, what happens if I just block all traffic to the database and pretend that it's down, right? My application doesn't necessarily have to work, but I would expect on my service that I would get some sort of alert. My monitoring tool would say, hey, the database is down, you can't connect to it. And maybe my users get some sort of, reasonable error message as well.
I guess if you can tell what will happen, something wrong, you don't need to test. But I guess the problem is, you mentioned this at the beginning, where you have some hypothesis, because some developers would say, oh, nothing would happen to the database because I'm using this super smart client that pulls the DNS and I don't know, does like automatic reload and always looks at the dynamic address of whatever. And then it's a hypothesis, and then you're like, okay, let's test it, right?
Yeah, and the great thing about when you're testing these things out, right? Like, let's say that you do have some sort of database connection framework and it handles all of that. That's fantastic. Test it out, and if it works, then great. Like, you can sleep much better at night knowing that you're using a thing and it works. And if the database ever goes down, you won't have these issues. But what if it doesn't, right? You need to be certain. So you have that hypothesis, go test it out. If it works, great. Sleep well tonight. But if it doesn't work, that gives you an opportunity now, again, as we talked about being proactive, is you found a flaw, you found an issue, and it could have been horrible. That could have happened on the busiest day of the year when all of your users are active, but you found it at a time where you were in control, you were watching the systems, and you were able to actually control that and find that issue. And now you can go fix it. And once you fix it, then you can retest it. And hopefully then again, you'll sleep better at night knowing that it's actually working now.
So now that you're talking about this, I feel like it's an important prerequisite is having visibility.
Yeah, you absolutely have to have some sort of monitoring observability tool to get those metrics to actually be able to see what you're doing. Now, that said, a lot of people are like, well, I've got Prometheus and Grafana installed and it's okay, but I know that it's not that great or whatever. It doesn't have to be perfect, right? One of the things that you'll discover as you're doing this is you inject some sort of failure, you cause a minor incident from it, and you realize, oh, if this was in production, if this really was an incident, I don't have those metrics to debug this. And so there's a nice loop here where you can use chaos engineering and you can find the information that you might be lacking. And so you can add new dashboards or gather new metrics. And that way, if something happens for real, you've got that information. And so you can kind of use chaos engineering to improve monitoring and then use your monitoring to improve your understanding of incidents that makes your chaos engineering better.
Now I understand why you said it's a great way to promote visibility tools.
Yeah.
So I want to ask you about tools today. So you mentioned Chaos Monkey before of Netflix, and there's Gremlin. So let's hear a little bit about this, because I know it's not that, but I wonder if it's the first time I hear about it. Okay, so why would they need some tools for this? Because basically you're telling me to kill pods or delete instances, or I don't know, if I want to, maybe I'm being creative, quote unquote now, I want to increase CPU, I'll just run this BusyBox container that will consume a lot of CPU. So what is Gremlin? And I guess what tooling do you need in place?
Yeah, so that's a great question. There's a lot of aspects to that. So the first thing that I would say is absolutely, you don't need a tool to get started.
Oh,
so
okay.
Go ahead and, kubectl, delete pod, or, if you're in the cloud like AWS, go into the AWS console and kill an EC2 instance. And if it's in an auto scaling group, you should be able to see it come back. There's a lot of really easy ways to get started. And so that's a good point to do it. But I'll give you a story. I once was testing a system, back in the early days before I was at Gremlin. And it was that notion of like, what would happen if my network connection for this very simple web app went out, right? And so I, being a smart guy, I SSH into the server and I'm like, cool, well, how did you do that, right? How do I take out the network? And I'm like, well, I want to be very, very controlled in this. So I'm going to just like go and edit my IP tables. And I know what the IP address range is for the traffic that's coming in, the ingress point, and I know what I'm serving out. And so I go and I'm a reasonably competent ops engineer. I go and I change the IP tables and I, save that. And, Linux is now using it and instantly SSH connection terminated.
Oh, so basically you lock yourself out of the system.
I did. Yeah. And so it's that thing of like, replaying it in my head as like, what happened? I know I'm locked out now. Like, how can I get back into this? And I realized that I'd probably made a typo in that entry that I'd made. And so there's this notion, right? That story, very simple example. And, to be honest, not ashamed to admit that it's happened several times, not in the exact same way, but safety becomes a big thing as you're testing your systems. Obviously, there are plenty of tools that you can do, and I do suggest doing it manually. But at some point, you reach a level of testing where really bad things could happen. And so you want a tool that actually helps you out with that, right? That is safe, that if you run some sort of test, that you won't get locked out, that whatever's built into that system will have safety features and automatically roll things back for you. And so that kind of leads to the next part of the question, which was about Gremlin. So Gremlin was actually founded by two engineers. So our CEO, now CTO, Colton, actually came from Netflix. He was part of the team that was building out the culture of chaos engineering there. And he worked on basically the second version, or the fancier version of Chaos Monkey, I'll call it. And he had the idea of, what if we made this available to everybody, right? Because the tools we're building now are just for Netflix. So he joined with a buddy of his, a guy named Matt Fornachari, who had also done a bunch of chaos engineering stuff at companies like Salesforce and Amazon. And so they came together and founded Gremlin. And so that's really what Gremlin is it's a platform that helps you do chaos engineering in an easy and a safe way. And so everything that we build defaults back to safety. If it encounters an error, or you can hook it up to check your monitoring tools. If something bad happens, it's designed that it can immediately start to roll back so that it doesn't take down your systems.
It would have to really know your system, right? Because it's so delicate. It's not like it's a CI/CD platform where we're like, okay, I just deploy stuff to Kubernetes. You have to look at stuff and know how to break them and measure this. And I guess I wonder, like, what are the options? Like, okay, I have the platform. So how would that work? Let's say I want to start tomorrow with chaos engineering and I want to use Gremlin. I've tested a little bit. I SSH'd myself out of servers. Now I'm locked. I want something more organized. So how do I start with Gremlin?
Yeah. So the great way to start with Gremlin as a commercial offering, we do have a fine solutions architecture team. So often what happens when someone comes to Gremlin and becomes a customer, or even as they're considering becoming a customer, sort of in that trial period, I would say, is we'll have an engineer come alongside your team, help you install the tool, train you up on how to use it, including your team, and run through some chaos engineering experiments with you. And so oftentimes they'll take a look at your systems. They'll ask you about recent incidents that you might have had. And so they'll get an understanding of either, let's try to replay that incident and learn from it, or here are the areas of your system that we think are particularly vulnerable to incidents or outages. And so here's how we can test those. One of the great things that I should mention is we've got a fantastic team of engineers and product folks. And so they're actually trying to take some of this and build it into the product to make it easier. So when you start with Gremlin, the future of Gremlin is eventually going to be having the system make recommendations to you on things that you can test.
Is it correct to say that if, sometimes getting a demo and starting this thing is maybe too much, and maybe if I want to start with little baby steps, I can look at Chaos Monkey?
Yeah, Chaos Monkey is, I don't recommend people start there simply because it's, coming from Netflix, it's very opinionated. So you have to be basically running Spinnaker as the deployment because that's what it integrates with. And so there's a lot of assumptions that it makes around, what you're running based on what Netflix was running. That said, there's also a ton of great open source tools out there. So if you're like, I just want to get started simply and I've done the manual thing, a few of the open source tools out there that I particularly like are Chaos Toolkit. Chaos Toolkit's written by a guy named Russ Miles, who's been in the chaos engineering community for a long time. Chaos Toolkit was actually what we used at Datadog initially, before Datadog wrote their own, what they call Chaos Controller, which is a Kubernetes thing. And it's also open source. So if you're on Kubernetes and you're looking for something, check out Datadog's GitHub. That's where the Chaos Controller lives. There are also a few other tools, part of the CNCF ecosystem or landscape. So within CNCF, I think there's Chaos Mesh and there's Litmus Chaos, which are two other tools.
Okay, cool. So there's a bunch of things. And kind of what are the features of creating chaos? I'll explain it. I can easily imagine a feature where there's a button and it's like kill a pod. Okay, cool. Or delete a full deployment, or black hole, as you said. So you change the ingress target. And what else? Like, what can we do to, what ways we have to generate chaos?
Yeah. So there's a lot of different ways. So with Gremlin's tool in particular, we've got 11 different types of tests, or sometimes we refer to them as attacks. But the 11 are, there's resource level ones. So consuming CPU, consuming memory, disk space, and IO. So those are all really helpful for really just testing what would it look like if my systems are stressed, if they don't have enough resources. So oftentimes people use those to test for things like, does my auto scaling work? Or do I have enough capacity if I were to receive a surge of traffic? Things like that. Then we have network level tests. And so on the network with Gremlin, you can black hole things, which again is dropping traffic from, configurable ingress points or blocking traffic heading out to various places based on hostname, IP, et cetera. So black holing. Then we also have the ability to drop or corrupt packets. So really test if you are on a flaky network. The other ones that we have then are introducing latency. So really testing the performance of your system. And then as everybody knows the meme, it's always DNS. So we have the ability to block DNS as well.
Sure.
So that's the network level ones. And then the final ones are what we call state tests. And so these are things like shutting down servers. So imagining that you lose an EC2 or any type of VM or container. So yeah, killing servers, killing containers, also killing processes. So what happens if a process dies? And then the final one that we have is to skew the system clock. And so I particularly like this one. Yeah, because we all assume that, NTP is going to be working and time is always going to be totally fine, except when it's not
that's so true.
Daylight savings time. Yeah.
Like even the phrase of on AWS, all the EC2 instances are synced with their NTP servers. So nothing to worry here.
And the funny thing is, even when your time on your systems is accurate for NTP, you'll want to test for things like time changes, because usually what I've found is, time zones are crazy hard. As we've discussed earlier, like scheduling this with the time zone between US West and Israel was a little tricky.
Yeah.
But, you're oftentimes, for me, it's always the application side. So I'll give you a great example from when I was at Datadog about time zone issues. At Datadog, when I was there, we released this machine learning feature for anomaly detection. And the idea was, if we could see a trend in how your metrics are behaving and what spikes are normal, you can get better alerting, right? You don't have to set a static threshold. You could just say that, on Wednesday morning at 8 a.m., we normally see low traffic, and now we're seeing a spike. And so the system can detect that. And early on, one of the issues that we had actually was around daylight savings time. You train this machine model that learns every morning at 8 a.m. on Wednesday, there's no spike. And then suddenly time shifts an hour. And it's like this pattern that I saw normally is not happening. Like, what's going on? And it would throw like false alerts. And we realized like, oh yeah, daylight savings time is a thing. So this is exactly why you want this, right? Like, use a tool like Gremlin or a chaos engineering tool to change your clock and see what happens to your systems when suddenly it thinks things are an hour off.
Okay, so that's super interesting. I guess it's not something you can start doing right away. As a startup, you're focusing on, product market fit and like quick and dirty and delivering value to the customers, like, just startup stuff. And then at some point, I think it's more suitable. With that said, what's the right time to start introducing chaos engineering into an organization? And also, who are the right people or the key people to do it with?
Yeah, great questions. Because, you're right. There sort of is this feeling of, I don't want to optimize too early, right? I don't want to focus on things when really right now is an early stage startup. I just need to be building features and pushing them out there, like deliver that value. But obviously, at some point, you get to the scale where reliability is important, and the amount of money and the amount of loss that you have for an incident is huge. So I always recommend that, yes, just start early, but also start simple. Again, that first test that I always run, if I turn this off, does it automatically come back, right? If that's all you're doing, that's fine. Like, that's a good place to start. And you could probably go for a decent amount of time with just running that test, right? Easy to have in your pipeline of when it spins up that test environment, first thing you do is just like kill the service, see if it, wait for whatever amount of time, but it should come back, and then run the rest of your tests. So it doesn't have to be really onerous, right? You don't have to go from that to immediately saying, we're going to test our multi-region and fail over like one region. Because at that point, you probably don't even have multiple regions, right? So I'd say start it simple. And as you grow, start to think of, the things that you can do. One easy way to do that is just start expanding, right? Like, as you're growing and your systems become more complex, you're going to be prone to more incidents. So a good way to grow is just to take those incidents that you've had and replay them, right? You have an incident, you go through a postmortem or root cause analysis, you find that issue, you make the tickets, and eventually those get fixed. So then try to recreate that with chaos engineering tools, recreate that incident, validate those fixes. And that's a good way to grow your chaos engineering as you organically grow.
It's amazing because like you do postmortems around incidents that matter. And actually, it's a good idea, like how you pick the most important. This is what you want to do. You want to never actually have this incident again.
Yeah, it's really interesting too, because as you're doing the postmortem and you find those fixes, obviously, like, those fixes are a lot of times they're going to be in code or they're going to be in infrastructure. And so, you make that code update and then you write like unit tests or integration tests to actually test that thing. Well, why not add a little bit of chaos engineering testing, right? Chaos testing in there to also validate that this fix you wrote will actually solve or prevent that incident, which is why you were doing the work in the first place.
And also to validate that people did the work. So, because, sometimes you have this like tons of action items and it's super complex. And then sometimes the urgent thing pushes out the important things.
Yes.
And then you kind of don't do it. But if you actually repeat the incident. So, okay. So this has been so interesting. And I wonder, is there anything else like you feel we must know about chaos engineering that we did not discuss yet?
Yeah. I mean, I think a few other things of chaos engineering. So I've mentioned, starting simple, starting the easy way, and then just organically growing. I would say one of the resources that I particularly love that we've built at Gremlin is a chaos engineering certification program. So there's 2 levels of that. If you go to gremlin.com/certification, you'll get the information on that. So my colleague Julie wrote a lot of that in conjunction with some others. So it's a fantastic place to get started, even if you feel like I'm not quite ready to actually practice this, to do it. You can at least learn what's involved. And so there's some great educational materials.
Found it. I'll put it on the show notes as well. Cool.
The only other thing that I would say is don't overthink it. It sounds crazy complex. It sounds like it's going to add a lot of extra work to what you're doing. And honestly, if you start simple and you start small, it really isn't. So my encouragement is just go do it. Whether you feel like you're a super confident engineer and everything you build is amazing, well, go test that and ensure that you are a fantastic engineer. Or if you're feeling less confident, you're like, everything that I write, everything in our systems, it's just garbage, it's broken. Well, start working on it, right? Cause that. So if you're in a small system, everything's broken, just do it. Don't overthink things, just get started.
Sure. So this is a great mantra for life even, Thank you for this. It's actually been very, very interesting. I feel like, there's like this whole notion of DevOps evolution where you yourself worked like, it's a little bit of IT with like servers and the actual hard drives. And then you moved to the cloud and the DevOps notion became, and then there's like production engineering and SRE and all this notions. And I feel like chaos engineering it's kind of like the missing step to it all. It's like where the future goes. And then like, what's the next step? Oh, break your own system, test it, like validate it. Don't wait for the incident.
Yeah, exactly.
All right. So thank you for this. Yeah. Where can we follow you? Where we can hear more about you? And like, if there's anything else to say, like you guys are hiring or like for demo product.
Yeah. So a few things. The YouTube is just youtube.com/reliability-engineering. So I've been posting videos. I've kind of taken a break, but I'm hoping to get back to that soon. Everywhere else, I'm git bisect. So if you don't know the git command, git bisect, I highly recommend that you look at it, but GIT-BISECT. So you can find me at Git Bisect on LinkedIn and Twitter. So those are how you can get a hold of me. My DMs on both platforms are open. So if you have any questions, feel free to hit me up there. I think the second, in terms of getting started, Gremlin.com is a great place. Gremlin.com/community actually is the URL that you probably want to hit. That's really everything that you need. So that'll link out to not only the certifications that I mentioned, but also a bunch of other resources, tutorials that you can read, and the Slack community. So we've got a chaos engineering Slack. There are over 8,000 people in that Slack. So that's a good place to join as well to find out more information.
Amazing. Thank you. And one last question I like to ask, is there a recommended book that you recommend?
In terms of chaos engineering, there's a fantastic book by Manning, the publisher. And so Mikolaj Palikowski is the guy that wrote that. He's been an engineer at a bunch of organizations, but I particularly like that book. It's a very pragmatic approach to doing chaos engineering.
Thank you for kind of being here with us today. It was super interesting and incredible. עד כאן פרק נוסף של בוקר קוד. עקבו אחרי עמוד הפייסבוק של הפודקאסט בוקר קוד על מנת להתעדכן בתכנים מעניינים, ותמיד ניתן להזין לפרקים בכל הפלטפורמות האהובות עליכם, בספוטיפיי, אייטיונס, גוגל, פודקאסט וכל אפליקציה אחרת. מקווה שנהנתם מהפרק למרות האנגלית השבורה שלי, ותודה רבה לכם.